These are the fields which are available in the frame structure. It has six fields: flag, address, control, information, and FCS. We'll see about each of these fields in detail. First, about the flags. So the flag bit helps in the frame identification. That is, it will be present in the beginning and the end of the frame. It acts as a delimiter, and the value of the flag is zero followed by six ones. And this is the indication that it is a flag bit, and this is the indication that the frame, beginning of a frame. And if the receiver obtains this kind of value, then it will check whether it is the actual flag or whether it is the actual data. So to avoid the confusion with the data and the flag bit, the padding process will happen, and this process is called as bit stuffing. So what happens if the data, actual data contains consecutive five ones, then at the sixth bit, some zero will be added. This is called as the bit stuffing process. And at the receiver side, this will be checked continuously and it will be understood. So if the receiver detects five continuous ones and it checks the next bit, which is very important. If the next bit is zero, then it is deleted, which means that is a padded zero, so it can be deleted. And if the sixth bit is one and the seventh bit is zero, which means six continuous ones means it is a flag bit, so it is a flag bit and accepted. Otherwise, if the sixth and the seventh bit are continuous ones means, then it should be aborted. It is an indication it should be aborted. So this is the about the flag bits. This picture tells about an example of bit stuffing process. Let's take this as an original data pattern since it has continuous ones. So what has been done after every fifth bit, a zero is being added along with it and sent for transmission. And at the receiver end, the zeros are being removed and the actual value is obtained. This is the bit stuffing process. Then coming to the address field. So the address field contains the secondary station's address. It can be one secondary or a number of more than one secondary stations. So that's why it is usually 8-bit long. Otherwise, if it has to include more than one secondary station address, then the address field can also be extendable. So for maximum, it can be extended up to a multiple of 7-bit size. If suppose you want to go for a frame broadcasting, then the address should contain all ones. 8 continuous ones should be present. So this is the detail about the address field, which is an extendable field. And the third one is the control field. The control field tells about the control operations or control options which is being present in the particular frame. So the control options are being splitted up into three categories, which is kept under three frame types: the I frame, S frame, and U frame. I frame representing the information frame. As the name tells, it contains the information about that particular frame, the sequence number, and whether it is a pole or final. Some details about it will be present. So the data to be transmitted to the user, and then some piggybacking informations. And coming to the next frame, which is S frame, which is a supervisory frame. This is particularly used for the monitoring purpose. So it contains a flow and error control features. And the third one is the unnumbered frame, which contains some additional link control options. So all of these frames will be explained clearly in the next slides. And the identification of the frame type. When you look at the first two bits, that itself enough for identifying the type of the frame. So this slide contains the control field diagram. So when you look at this, the first two bit define the frame type. Zero means it represents the information frame, and 10 means supervisory frame. And if the first two bits are ones means, then it is unnumbered frame. So let us look into the first one. And one more thing, this control field can be two types. It can be a 8-bit frame field or 16-bit field. So let us look into the 8-bit field. So in this 8-bit field, the information frame contains n of s, p slash f, and n of r, which means the n of s and n of r represents the send sequence number and the receive sequence number. P slash